Section 4.1 is an introduction to matrices. A matrix is a rectangular array of variables or constants or numbers that are put in rows and columns and enclosed in brackets. Here you see a matrix. It's a way of organizing some numbers. A couple things about this matrix: it has 3 columns, 1, 2, 3, and it has 4 rows. Every element in the matrix can be described using its row and its column. So the number 15 here is in the 4th row, 2nd column. The word element is used to describe each number in this case, in this matrix, and we say a matrix has a certain dimension, and it's measured by its rows and its columns. This one over here is 4 rows by 3 columns. So if we go down here and state the dimensions of matrix B, this one has 3 rows and 2 columns. So we say it's a 3 by 2 matrix. Here's an example where we'll take information and we'll organize it using a matrix. Sometimes you'll see this on the ACT where they'll give you information in a matrix and then ask you some questions based on it. This one we have 2 tables. We have metro cable and we have city cable. So we're going to compare those two using a 2-row matrix, and there are 5 things that I'm comparing. I'm comparing basic service, standard service plus 1 premium, standard service plus 2 premiums, and standard service plus 3 premiums. And so let's compare them. Metro cable has $11.95, $30.75, and then you can go and fill the rest of these in. And now we'll do the same with city cable. So this allows us to take the information and organize it in a way that we can maybe answer a question about. So when is each company less expensive? So here, city cable is the way to go. For standard, you go metro cable, city plus 1 premium, city, and city. So it looks like metro is the only one that's cheaper if you get the standard cable. Here are more terms we use when dealing with matrices. A row matrix is a matrix with only 1 row. It looks like something like this maybe. And a column matrix has only 1 column. So this one has 1 column, 2 rows, something like that. A square matrix has the same number of rows and columns. So maybe something like that. A 0 matrix has every element that's a 0. There's an example of a 0 matrix. And then matrices that are equal have the same dimensions and the same elements. So here we have all the same numbers, but the dimensions aren't the same. This is a 3 by 2 and this is a 2 by 3, so that won't work. This one, same dimensions, and most of the numbers are the same, but 8 and 2 are switched, so that can't be equal. And these 2 matrices are actually equal. They're both 3 by 3s, and every element is the same. Here's an interesting use of matrices using equations. Because these 2 matrices are equal, then we would say that every element is equal, so we would say that y has to equal 6 minus 2x. And we would also say that 3x has to equal 31 plus 4y. It's just another way of writing these 2 equations, except we use matrices. Now if we solve this, it looks like substitution would be the way to go here. I'll substitute all that stuff in for the y. Then I'll continue to solve by distributing. So 24 minus 8x. These are like terms that are on the same side. So 31 plus 24 is 55 minus 8x. I'm going to bring the negative 8x over by adding it. So 11x equals 55, and then we'll divide by 11. So x equals 5.